Good morning, students. I am Savita B, working as Associate Professor in Mathematics. In this video, I am going to explain Gauss elimination method to find the solution of linear simultaneous equations. This video is useful for 5th semester BSc students. Now, what is Gauss elimination method? This is one of the direct methods to find the solution of linear simultaneous equations. In this method, unknowns are eliminated successively and the system is reduced to an upper triangular system from which the unknowns are found by back substitution. This method is general and is well adapted for computer operations. Now, what is an upper triangular matrix or upper triangular system? The elements below the leading diagonal are 0. So, given a system of linear simultaneous equation, we write the equations in the matrix form Ax is equal to B, where A is a coefficient matrix. We reduce the coefficient matrix to an upper triangular matrix using elementary row transformations, from which unknowns are found by back substitution. Okay, so let us understand Gauss elimination method. Consider a system of linear equations a1 into x plus b1 into y plus c1 into z is equal to d1. Second equation is a2 into x plus b2 into y plus c2 into z is equal to d2. Third equation is a3x plus b3 into y plus c3 into z is equal to d3. So we have a system of three equations in three unknowns or three variables x, y, z. Okay. So the method is eliminate x from the second and the third equations. How to eliminate x from the second and third equation? We multiply the first equation by a2 divided by a1 and subtract it from the second equation. So x is eliminated from the second equation. Coefficient of x here is a1. So we multiply the coefficient of x in the second equation, that is a2. So we multiply the first equation by a2 divided by a1 and subtract it from the second equation. So x is eliminated. Now let us eliminate x from the third equation. Coefficient of x here is a3 and coefficient of x in the first equation is a1. So we multiply the first equation by a3 divided by a1 and subtract it from the third equation. So x is eliminated. Hence, we get a new system of equations a1x plus b1y plus c1z is equal to d1. X is eliminated. Therefore, b2 dash y plus c2 dash z is equal to d2 dash. X is eliminated here. Therefore, we have b3 dash y plus c3 dash z is equal to d3 dash. Now, these are the new coefficients b2 dash, c2 dash, d2 dash, b3 dash, c3 dash and d3 dash. They are all new coefficients. Okay. Now, look at this. a1, b2 dash and c3 dash are called pivots or pivot elements. Okay, these are known as pivots. Now the second step is eliminate y from the third equation. Okay, consider the pivot element. Eliminate y from the third equation. How to eliminate y? We multiply the second equation by b3 dash divided by b2 dash and subtract it from the third equation. Okay, so the first equation is unchanged. Second equation is also remains same, whereas the third equation becomes c3 double dash z is equal to d3 double dash, where this is eliminated. Okay, so the second step is eliminate y from the third equation. Therefore, we have a1x plus b1y plus c1z is equal to d1. b2 dash y plus c2 dash z is equal to d2 dash. C3 dash Z is equal to D3 double dash. Now look at this. The last equation contains only Z. So we can find z, isn't it? We can evaluate z. So once we find the value of z, we substitute in the second equation and find y. So y and z are known now. Let us substitute for y and z in the first equation and find x. Therefore, z, y and x are obtained. That is, evaluate the unknowns x, y, z by back substitution. Hence, in Gauss elimination method, we reduce the matrix to an upper triangular matrix. We reduce the coefficient matrix to an upper triangular matrix, isn't it? So this method fails if one of the pivots a1, b2 dash or c3 double dash becomes 0. So in that case, equations are rewritten in a different order so that the pivots are non-zero. Okay, if a1, b2 dash or c3 dash are 0, that is, if these pivots are 0, we rewrite the equations in different order so that we get non-zero pivots. Okay. Now suppose if you write the system of equations in the matrix form Ax is equal to D, then Gauss elimination method is nothing but transforming the coefficient matrix to an upper triangular matrix using elementary row transformations only. So we have understood Gauss elimination method. This is one of the direct method to evaluate a system of linear equations. Okay. Now using this method, let us solve one problem. The problem is, using Gauss elimination method, solve the equations x plus 2y plus 3z minus u is equal to 10, 2x plus 3y minus 3z minus u is equal to 1, 2x minus y plus 2z plus 3u is equal to 7, 3x plus 2y minus 4z plus 3u is equal to 2. So, we have 4 equations in 4 unknowns x, y, z, u. So, let us solve these system of equations using Gauss elimination method. First, let us write the equations in the matrix form Ax is equal to D. A is a coefficient matrix whose elements are 1, 2, 3, minus 1. Second row elements 2, 3, minus 3, minus 1. 2, minus 1, 2, 3. 3, 2, minus 4, 3. So this is a coefficient matrix. Then we have capital X, that's a column matrix, X, Y, Z, U. Matrix of unknowns is equal to, again a column matrix, which is 10, 1, 7, 2. Okay. Now let us reduce this coefficient matrix to upper triangular matrix, which means the elements below the leading diagonal are 0. Okay. So, E element 0 agbeku, E element 0, idu 0 agbeku. Puna E element 0, idu 0. So, ishtu ottu 1, 2, 3, 4, 5, 6 elements annu namage 0 madlikide. Now, let us perform elementary row operations. Let us begin with the second element of first column. Since this is equal to 2, we multiply R1 by 2 and subtract it from R2. So the first row operation is R2 minus 2 R1. Okay, let us perform R2 minus 2 R1. The first row remains the same. We don't have to change the elements. So first row of the matrix is 1, 2, 3, minus 1 and 10 on the right hand side. R2 minus 2 R1 gives 2 minus 2, 0. 3 minus 4 minus 1 minus 3 minus 6 equal to minus 9, minus 1 plus 2 is equal to 1, 1 minus 20 is equal to minus 19. Okay. Next row operation is, look at this element, next row operation is R3 minus 2 R1. Okay. R3 minus 2 R1. So we have 2 minus 2 is equal to 0. Minus 1 minus 4 is equal to minus 5. 2 minus 6 is equal to minus 4. 3 plus 2 is equal to 5. 7 minus 20 is equal to minus 13. Okay. The second row operation is also over. Now let us make this element 0. Okay. How to make this element 0? Since it is equal to 3, we multiply R1 by 3 and subtract it from the last equation, that is R4. So the third row operation is R4 minus 3R1. Let us perform R4 minus 3R1. 3 minus 3 is equal to 0. 2 minus 6 is equal to minus 4. Minus 4 minus 9 is equal to minus 13. 3 plus 3 is equal to 6. 2 minus 30 is equal to minus 20. Okay. So, these 3 elements 0 agide. Now, let us consider the diagonal. So, 1 minus 1 minus 4, 6. This is a leading diagonal. ಈಗ minus 5 ಅನ್ನು 0 ಮಾಡಬೇಕು. How to make minus 5 0? We have to multiply the second row element, that is this element, by minus 5 and subtract it from R3. So the next operation, row operation, is R3 minus 5R2. So what do you get? R3 minus 5R2 gives minus 5 plus 5, 0. Look at the matrix. First row, second row, elements remains same. This is equal to 0. Your operation is R3 minus 5R2. So this element is 0. Now consider the next element. Next element is minus 4 plus 45. Minus 4 plus 45, which is equal to 41. Okay. Okay. Next element is 5. This is multiplied by 5. R3 minus 5R2. So 5 minus 5 is equal to 0. This element is minus 19 is multiplied by 5. So R3 minus 5R2 gives 82. So R3 minus 5R2 gives 41, 0 and 82. Next is, look at this. This element is minus 4. Minus 4. So in order to make this element 0, we multiply R2 by 4 and subtract it from R4. So the next row operation is R4 minus 4R2. R4 minus 4R2 gives minus 4 plus 4. So this is equal to 0. Then minus 13 plus 36, isn't it? Yeah, minus 13. R4 minus 4R2, once again. R4 is minus 13. This is multiplied by 4. So minus 13 plus 9 into 4. That is 36. So minus 13 plus 36. Yes, that is equal to 23. And the next element is 6 minus 4, which is equal to 2. Similarly, minus 19 is multiplied by 4 and minus 28 plus 19 into 4, which is equal to 48. Now observe the coefficient matrix. Except this element, all other elements are equal to 0. Okay, now let us make this element equal to 0. So operation is R4 minus 23 divided by 41 R3. So if I multiply third row by 23 divided by 41, then 41 gets cancelled. We are left with 23. Okay. So operation is R4 minus 23 divided by 41 R3. So this element is equal to 0. This does not change because it is equal to 0 here. So 2 minus 0 is 2. Then 48 minus 82 into 23 divided by 41, that is equal to 46. So 48 minus 46 is equal to 2. So look at the matrix now, coefficient matrix. The coefficient matrix is reduced to an upper triangular matrix. Elements below the leading diagonal are equal to 0. So by back substitution, we can find the values of unknowns, isn't it? Last equation is 0 into x plus 0 into y plus 0 into z plus 2 into u is equal to 2, which gives u is equal to 1, isn't it? Therefore, write the equations. So this system is equivalent to 1 into x plus 2 into y plus 3 into z minus 1 into u is equal to 10. Therefore, the system is equivalent to x plus 2y plus 3z minus u is equal to 10. I hope you are following. And the second equation is 0 into x minus 1 into y minus 9 into z plus 1 into u is equal to minus 19. and the last equation is 41z is equal to 82. The third equation is 41z is equal to 82 and the last equation is 2u is equal to 2. So we have these equations. From this equation we get u is equal to 1, z is equal to 2. Substitute for z and u in the second equation, find y. On substitution and simplification we get y is equal to 2. Substitute y is equal to 2, z is equal to 2 and u is equal to 1 in the first equation. On simplification we get x is equal to 1. Therefore, the system of equations are solved and the solution is x is equal to 1, y is equal to 2, z is equal to 2 and u is equal to 1. Hence, Gauss elimination method is reducing the coefficient matrix to an upper triangular matrix using elementary transformations only. I hope you have understood the problem. So, given a system of equations, we eliminate x from the second, third and the fourth equations. We eliminate y from the second, third and the fourth equation. We eliminate z from the fourth equations and we find u, z, y and x by back substitution. So this method is known as Gauss elimination method, which is one of the direct method to find the solution of linear simultaneous equations. Okay. Reference book is Numerical Methods in Engineering and Science with programs in C and C++. Thank you.